Hello everyone, this is Dr. Shaik Ruksana Begam working as Assistant Professor in the Department of Electrical and Electronics Engineering from Institute of Aeronautical Engineering, Hyderabad. Today I am here to deliver a lecture on star to delta transformation. So in the previous lectures we have learned how to calculate the resistances when they are connected in series, parallel and combination of series parallel. So here we are going to learn about how to calculate the resistances when they are connected in star and delta connections. So this star to delta transformation is a technique that we are going to learn how to convert the resistances or how to calculate the resistances when they are connected in delta and star. So this is the basic network of star and this is the basic network of delta. So in the upcoming topics, will be having this type of connections like star and delta. So if there are in the circuits we are containing star connection and delta connection, we are going to learn how to convert this star to delta and delta to star. So the star delta transformation is another technique useful in solving complex networks. Basically any three elements such as resistive, inductive, capacitive. This star connection or delta connection may be connected in either by using resistances or capacitances or by inductances. Mostly we'll be using star networks only. So this is the basic circuit of star and this is the basic circuit of delta. Star connection will be connected into delta and delta will be connected to star. So first we are going to learn how to convert star to delta transformation. So this star to delta transformation is a mathematical technique used in electrical circuit analysis to convert a three-terminal star network into a equivalent delta network. So first this is the star network. This will be converted into a delta network. This will be consisting of three resistances which can be either denoted with ABC 1 2 3 XYZ. It's according to your requirement. So this transformation simplify the circuit analysis especially in resistive and impedances network. So for your basic knowledge, we'll be seeing by connecting in the star connection to delta by using only resistances. So this is the star connected network with the three resistances and this should be converted into delta. The equivalent circuit of the delta is connected in this way. So for conversion of star to delta transformation, we'll be having some formulas which are basically obtained from the star connection. So first we see that. So now here I am drawing star connection. So this will be denoted with A, B, C. Either you can also denote with 1, 2, 3 or 1, 2, 3 or X, X, Y, Z. Depending upon your requirement, you can denote it as ABC, 1, 2, 3 or X, Y, Z. So first I am taking here as terminal A, B, C. So this should be converted into a equivalent delta circuit. Here I am drawing the delta network. So here I am denoting as 1, 2 and 3. So to convert this star network into delta, first we need to draw a dotted line so that which forms delta network. So I'm joining these 2 points and which are A NC and C and B and A and B. So which is forming a delta network. So here is the delta network. Now we are going to find, we are taking the resistances are RC, RA, RB. Now to convert this star network into delta network, first we should calculate for each terminal individually. So if it is A, first we have to take RA, then RB, and then RC. So for the first resistance, here is the node. So for the first node, R1 and R2 are connected. These are denoted with R1, R2. So for RA terminal, R1 and R2 are connected. So I am writing as R1 plus R2 plus R1 into R2 by R3. First, we have to add these two terminals which are connected to the resistance RA. So for the RA resistance, R1 and R2 are connected. So I'm first adding these two resistances which are R1, R2, and then we have to multiply these two resistance, and then we have to divide these resistances with the opposite resistance. So first terminal RA I'm taking as R1 plus R2 into R1 plus R2 plus R1 into R2 by R3. So if I consider RB, so for the RB terminal, R2 and R3 are connected. So I'm taking as R2 plus R3 plus R2 into R3 by opposite resistance is R1. First we need to add these two resistances, and then we need to multiply these two resistances, and we have to divide these two resistances with the opposite resistance. So if I consider the terminal RC, so for the terminal RC, R1 and R3 resistances are connected. So that we are taking, first we need to add these two resistances which are of R1 plus R3, and then we need to multiply, and then we need to divide with the opposite resistance which is of R. So these are the formulas to convert from star to delta. So this resistances can also be written as R1 into R2 by R1 plus R2 plus R3. So RB can also written as R2 into R3 by R1 plus R2 plus R3. In the same way, RC can also written as R1 into R3 by R1 plus R2 plus R3. So by using these formulas, we are going to convert the network from star to delta. So these formulas we'll be using to calculate in the problems. So first formula will be for the first node. If we consider first node, what are the resistances connected to the node? The resistances are R1 and R2. So first we have to add these two resistances which are of R1 plus R2 plus, and then we need to multiply these two resistances R1 into R2, and then we have to divide these two resistances with the opposite resistance. So the formula for the first node is taken as R1 plus R2 plus R1 into R2 by R3. This can also be written as R1 into R2 by R1 plus R2 plus R3. Either by using this formula or this formula, we need to calculate the resistances. So for the next terminal, if we consider RB, so R2 and R3 are connected to this node. So we have to add these resistances first. First R2 plus R3, and then we need to multiply these two resistances which are of R2 into R3 by, we have to divide these two resistances with the opposite resistance which is of R1. So in the same fashion, for the node 3, we have to add the resistances first. For this node 3, R1 and R3 are connected. So we are going to add these two resistances, and then we need to multiply these two resistances, and we have to divide these two resistances with opposite resistance. So first we are going to know what are the applications of star to delta transformation. First application is simplification of complex electrical networks. To simplify the complex network, we'll be using the star to delta transformation. And the second one is circuit analysis in AC and DC electrical systems. And third one is used in impedance calculation for balanced load. So these are the three applications used for star to delta transformation. So next, going to the delta to star transformation. This transformation is also used to simplify the complex networks. So the definition is given as delta to star. So it is denoted with delta, and the symbol of star is taken as Y. So transformation is a technique used in circuit analysis to replace the three-terminal delta network with an equivalent star network. This is useful for simplifying complex electrical circuits. In the previous, we have seen how to convert star to delta. So in this, we are going to know how to convert the delta to star transformation. So first, I am taking the delta network. So even if we consider star or delta, we'll be having three resistances. So this one we need to convert it into star. As I have already mentioned, we need to point this as either 1, 2, 3 or ABC. So I'm taking this RA, RC, RB. This is A, B, C, and this is denoted with R1, R2, and R3. So to convert this delta network into star, first we have to draw this star network inside this delta circuit. In the same fashion as we have converted star to delta, first we have to see at this node what are the terminals connected. So if we are calculating R1, and this is denoted with RA, RB, RC. See, if we consider this resistance R1, for this resistance terminals RA and RC are connected. So in the delta to star transformation, first we need to multiply all the resistances. Just and we need to divide this with opposite resistance. So for this opposite resistance is taken as RB. So in the same way, if we consider the element R2, for this R2, RA and RB are connected. Again, we need to multiply all the resistances RB, RC plus RC, RA, and the opposite resistance will be of RC. So if we consider the network as R3, so for this network, this R1 and R3 are connected, the opposite resistance will be RA. So RC and RB are connected, the opposite resistance will be taken as RA. First, we need to multiply all the resistances and we need to divide it with opposite resistance. So these are the formulas used to convert the delta into star transformation. So in the previous we have seen how to convert star to delta by using this formula. We are going to convert star network into delta network, and by using these formulas we are going to convert delta to star. So here are the few applications for the conversion of delta to star transformation. The first is simplifies the circuit analysis, especially in bridge and mesh networks. Second one helps in AC and DC circuit analysis, and third one is used in impedance calculations for electrical power systems. So these are the three applications of delta to star transformation. So first, for the conversion of star to delta or delta to star, we need to remember those formulas. By using these formulas, we are going to convert the circuit into star or delta depending upon the specification. So here are the differences of star to delta transformation. So here already we have seen to if the star network is converted into delta network, first we are going to multiply all the resistance and we are going to divide the divide the circuit with the opposite resistance. So here also we are going to multiply and then we are going to add the all resistances. So by using these formulas, we are going to solve the networks. So here is the example problem for delta to star conversion or the star to delta conversion. So first we have to see the network. So here is a delta network and star network. So we have, what is the question given? For the circuit shown in the figure, determine the equivalent resistance between two terminals. So specifically they have not mentioned the source across two terminals. They have given to calculate between any two terminals, so that we can take either these two terminals as source or this two or this two. So here is the delta network and here is the star network. First we have to convert this star inside star network into delta network. So here I'm going to draw the network of star. So all the resistances are taken as 4 ohms. So the terminal, sorry, X, Z and Y. Either we can take it as ABC, XYZ or 1, 2, 3. Now we need to convert this into a equivalent delta network. So here I am going to combine this network to form a delta circuit such that we can calculate the network easily. So now we are going to convert the star network into delta. So first if we consider these 2 points, so 4 plus 4 plus 4 into 4 by 4. For the first terminal, it is taken as either x or x is equals to 4 plus 4 plus 4 into 4. First we need to add these two resistances and then we need to multiply these two resistances and we have to divide these two resistances with the opposite resistance. So first these two resistances are with 4 ohms. So I have taken 4 plus 4 into 4 by 4. In the same way for the Z network, 4 plus 4 plus 4 into 4 by 4. In the same way for Y, 4 plus 4 plus. So the resistances of Rx, Rz and Ry are, so for Rx it is taken as 12 ohms. The values are same. For all the 3 points we'll be getting 12 ohms. So now we have to denote this here, 12, 12 and 12. So if we see the question, already here is a delta network which is having 4 resistances with 4 ohms. So this will be as it is. Again we have to redraw this network. So if we redraw this network, we'll be getting, So already there is a delta network. So now I'm going to connect this network across the previous delta network. So it can be connected in this way. X and Z. So one is of 12 ohms, and the previous network we are having the resistances values with 4 ohms. So now we have to yeah, now we have to check the connections whether these two connections are either connected in series or parallel. So in the previous class I have already told if the current is same across all the elements, then the network is said to be in series. If the current is dividing in the circuit, then the network is said to be in parallel. So if we see here, so the current is dividing over the all the terminals. So all the resistances, the current is dividing. So if we consider these two resistances and these two resistances are connected in parallel to each other. So first we have to reduce this network into a single delta network. So for this, first we have to convert this parallel circuit into a delta network. So we are using the formula which is of R2 by R1 into R2 by R1 plus R2. So if we calculate all these resistances connected in parallel, we'll be getting the values. So this is for X and this will be for Y, which is of R1 into R2 by R1 plus R2. So again for calculating for Z, R1 into R2 by R1 plus R2. So it will be taken as 4 into 12 by 4 plus 12. As the values are same for all the connections, I'm taking in this way. Now we have to convert this entire circuit into a single delta circuit. So for converting this circuit into a single delta circuit, first we need to calculate the parallel resistances so that we'll get a single value. The value of this will be, so the values of this resistances will be taken as 3 ohms. As we are having the same values, all the resistances will be of 3 ohms. So now by using this value, I'm going to draw the equivalent delta network. So the delta network will be redrawn in this way. So the terminal is taken as Y, X and Z. The resistances after calculation, after reducing this circuit, we are getting the resistance across each element is of 3 ohms. 3 ohms and 3 ohms. Now in the question they have given to find out the equivalent resistance of the network across any two of the terminals. Specifically they have not mentioned to calculate across XZ or XY or YZ. So they have said to calculate the resistance across any two terminals, because so that we am taking these two terminals as a sub source terminals. So here I am connecting the source. So the current is flowing in this direction. If then here it is dividing. So if the current is dividing, these two terminals, these two elements are said to be in parallel, and the same current is flowing across these two elements. So these two elements are said to be in series. First, we have to reduce the two parallel networks, which are of 3 into 3 by 3 plus 3, and that will be in series with, sorry, first I'm calculating these two series elements which is of 3 plus 3. which will be of 6 ohms. After reducing these two elements, the circuit can be redrawn as, so one is of 6 ohms and this 3 ohms will be taken as it is, and here will be the supply. So if we take the current direction, the current is dividing across these two elements, then these two elements are said to be in parallel. So here I am multiplying 6 into 3 by 6 plus 3. So the value of the equivalent resistance will be of 2 ohms. So here I am writing across the terminals X and Z, the equivalent resistance is taken as 2 ohms. In this way, we have to reduce the network if they are given in this way. So first we have to see whether which network can be reduced first. So first I am taking the star connected network and I am converting this network into delta connection. So after converting this circuit into delta connection, I am drawing this delta connection across this actual delta network. So if we draw here, we'll be getting the resistances. Again, we need to see the connections, whether they are connected in parallel or series. If there are any series and parallel connections, we have to reduce the network into a single equivalent delta network. After that, we need to calculate the equivalent resistance across either two terminals. If they specify, we need to calculate the resistance across the two terminals. If they have not specified, we have to take any two terminals as a source, and then we have to see connections whether they are connected in series or parallel, and we have to reduce that into a single equivalent resistance network. So for this question, the equivalent resistance is of 2 ohms. So that's it for today's topic. In the next topic, we'll be solving more problems on star to delta transformation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.